Hi everyone! This is the second video in a two-part video about squares, square roots, and perfect squares. In this video, we look at nth root and how to solve it. So let's start by figuring out what an nth root really is. So when you have a square root, like that of 16 for example, we talk about what number multiplied by itself 2 times will give us 16. If we look at the cubed root, like that of 27 here, for example, then we simply mean that one number multiplied by itself 3 times can give us 27. So you might be seeing a pattern here. If I say square root, then it's what number multiplied by itself 2 times. If I say cube root, then it is what number multiplied by itself 3 times. Let's look at another example. If I say the fifth root of 32, then we have to find out what number multiplied by itself 5 times gives us the desired number under the radical, which is simply 32. So essentially, this is the idea of nth root. Here, the nth root of x is asking us what number multiplied by itself n times will give us x. To solve this, one way would be factoring. But here, simply by looking at it, we can say that 3 would be the cube root, as 3 times 3 is 9, and 9 times 3 is 27. And this we know is going to be 2. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, and this is the value we want. But again, if you don't know this from the top of your head, it's absolutely okay. You could factor to get the answer. So 2 goes into 32 16 times. 2 again goes into 16 8 times. Then 2 4s are 8, 2 2s are 4, and 2 1s are 2. So the idea of factorization is basically dividing the value under this L shape by its smallest factor, excluding 1. So from here we can see that it is 2 multiplied by itself 5 times, which is exactly what we want. And this is the concept of nth root. Now let's look at a practice problem. What is the nth root of 125 if that is equal to 5? So what this means is 5 multiplied by itself how many times, or n number of times, gives us 125. In the exponent form, this would be 5 to the power of n equals 125. To solve for n, we can take the nth root of both sides. So these two would cancel out, and this leaves us with the nth root of 125. To solve, we use factorization once again. So the smallest factor of 125 is 5, and when I solve this, I see that 5 goes into 125 3 times. This would mean that the third root of 125 is 5, or even better, the cubed root of 125 is equal to 5. Now, if you're getting confused about converting between exponents and roots, here's a little trick. Firstly, we need to know that if we have 3 squared to be 9, this is the same as saying 3 is equal to the square root of 9. If I have 2 cubed to be equal to 8, this is the same as saying 2 is the cubed root of 8. So the trick I'm going to show you now is something I learned myself. If I have a tree and I have a number 25 up here, think about what roots of the tree can somehow multiply to give us 25. Now you want the roots or the base of the tree to be equal so that the tree is balanced. So we're asking ourselves what equal roots in the base can multiply to give 25. When we solve by factoring, we see that 5 times 5 gives 25. If we were looking at the cube root, then we'd say that if I had a number like 64, then what 3 equal bases or roots are there which will give me the value of 64, and that turns out to be 4. Now let's look at how we would work with roots in various problems. If I had the cube root of 250, We could factor, but 250 does not factor nicely into three whole numbers. So to solve this, we would split this up by saying that this is the same as the cube root of 125 times 2. Using the surd laws, we further say that this is the cube root of 125 times the cube root of 2. We know from a while ago that the cube root of 125 is 5. As for the cube root of 2, this is saying what number multiplied by itself 3 times would give me 2. Well, this is not going to be a whole number from the looks of it, so we can simply leave it like this or punch it into the calculator. But this is in its simplest form, so the answer would simply be 5 times the cube root of 2. The same works for division as well. If we have the square root of 9 over 4, this is the same as saying the square root of 9 over the square root of 4. The square root of 9 is 3, and that of 4 is 2. So our answer would be positive or negative 3 over 2. But remember, you cannot do the same for addition or subtraction. If I have the square root of 5, for example, we cannot say that this is the same as the square root of 2 plus 3. This would be wrong. Similarly, if I have the fourth root of 37, this is not the same as the fourth root of 40 minus 3. This would be completely wrong. So this situation of splitting up works only for division and multiplication. Thank you.